Alright, let's look at linear programming. Linear programming is a method for finding the max or min value of a quantity that is subject to various limitations. One of the key elements is the objective function. That is going to be an algebraic expression with two or more variables describing the quantity that we're maximizing or minimizing. Z is going to represent the objective function, and it's usually a function of x and y. So z equals ax plus by is usually what it looks like. And then the system is bounded by some constraints. It will be a system of linear inequalities that will create a shape in the first quadrant. We'll talk about that. And the edges or vertices are called corner points. So in order to solve a linear programming problem, that is finding the max or min, we're going to start with the objective function. We will graph the system of inequalities representing the constraints. The constraints are rarely given as inequalities. They're usually written in the story or in a sentence, and we have to interpret that into an inequality. And then we're going to find all the points that these inequalities in feasible region, the shaded regions, intersect. That creates our corner points or vertices. And then we find the maximum or minimum that we're looking for. All right. So this example is not linear programming, but we use this process later on in the linear programming problem. So what we're going to do is just start with this as exercise. So we have an objective function, z equals 5x plus 3y. They want us to find the value of that objective function at each corner point. So what we've done is I've already drawn the linear inequalities. We got rid of everything except for the shaded region where everything kind of overlaps. And these are the corner points. So the value of the objective function at A is, so I'm going to come over here. I'll do my work. So again, here's my objective function, z equals 5x plus 3y. For point A, which is 410, all you do is you plug in 4 for x and 10 for y. And you substitute, you solve that. So 5 times 4 plus 3 times 10. All right, you can type this directly in the calculator. 5 times 4 plus 3 times 10 is 50. Okay, so 50. The value at B, well, B is 8,5. So Z equals 5 times 4. Oops, sorry, 5 times 8 plus 3 times 5. So 5 times 8 plus 3 times 5 is 55. So far, B is the maximum. We'll see what happens with C and D. C is 9,3. So 5 times 9 plus 3 times 3. Let's see what we get there. 54, so B is still in the lead. All right, and then finally D is 2, I don't think that's going to be the maximum because those are small numbers. 5 times 2 plus 3 times 2. All right, so that's 16. I'll double check it just to make sure. 5 times 2 plus 3 times 2. So looks like the max, oh, and that's 16. So the maximum value of the objective function is the maximum that we found, which looks like 55. And the minimum value is the smallest number, which is 16. Okay. So there you go. So that's kind of the last step with the linear programming problem. So if you understand that, you understand the back half of these problems. All right, so let's look at an example. You're going to have a handful of these examples where you have to do the entire problem. I like this one because it kind of guides us along the way. So I always like to do this one in class. So a student earns $14 per hour for tutoring and $9 per hour as a teacher's aide. That's TA. Let X equal the number of hours each week spent tutoring, and Y is the number of hours each week spent as a teacher's aide. All right. So the objective function is what we're trying to maximize. In fact, later on it asks us to maximize the amount of money that the student can make. So the objective function, of course, I'll start up here. I might need all my space. Is AX plus BY, right? Well, it says that X is the number of hours tutoring. Okay, so X is the number of hours tutoring, and that is right here. So we can make $14 an hour tutoring. And then $9 as a TA, and it says Y is the number of hours as a TA, so that would be 9Y. Okay, so you're going to have to look for some of the kind of key phrases. So that's the objective function, Z equals 14x plus 9y. And you'll see a pattern in a lot of these. You can kind of jump to the end, but be sure to read through it. Make sure x is the number attached to tutoring, y is the number attached to TA. Okay, y. So now it says that the student is bounded by 3 constraints, and it wants an inequality for each one. So I'm going to do something interesting for 2 and 3, but number 1, it says, in order to have enough time for studies, the student can work no more than 15 hours a week. That means that the student could tutor 15 hours, they could be a TA for 15 hours, or some mix of that. And so the way we're going to write that, and this is going to be very similar on this problem and a lot of the problems, is the amount of hours that they are tutoring plus the amount of hours they are a TA, because that's what X is. Number of hours as a tutor, Y is the number of hours as a TA. The restriction is you have to work less than or equal to 15 hours a week. So you're going to see less than or equal to quite a bit. Technically, you could also put must be greater than 0. That's why we're only graphing the first quadrant in these. But the answer that my math lab wants is actually what we had first. So I'm going to circle that because that's the answer we want, even though it kind of says the same thing. So get used to doing what they want. The tutoring center requires that each tutor spend at least 2 hours a week tutoring. Okay. Well, tutoring is which variable? Tutoring is X. So they have to spend at least 2 hours a week tutoring. So they have to spend 2 or more. So our inequality will be X is greater than or equal to 2. At the same time, student can tutor no more than 7 hours per week. So that's a restriction on tutoring. Tutoring is also X. So this is saying that X has to be less than or equal to 7. No more than 7 hours means it could be 7 hours or less. At least 2 hours is 2 or more. And so those are our inequalities. Now, that's what they want us to type into my math lab. But I need to remind you that we can combine these two. Okay? Let me show you why real quick. So the reason I can combine these, we have x is greater than or equal to 2 and x is less than or equal to 7. If we have a number line, we put our two numbers. So x is greater than or equal to 2, we can shade everything to the right of 2. And if x is less than or equal to 7, we can shade everything less than 7. The intersection is what this means. It means where do those intersect? And they intersect right there. So it turns out that this phrase, which you're going to see, is the same as, well, it's basically saying x is living in between 2 and 7. So 2 is less than or equal to x is less than or equal to 7. Okay? These are the same thing. And so just for my notes, I'm going to remind myself that we can combine those and have 2 is less than or equal to x is less than or equal to 7. The reason why is I have to graph this inequality and these inequalities. But to avoid too much shading on my picture, I'm going to graph this. We know how to graph that from the last section. We treat it like an equation, then we test the point, solid line. This one is a little different, but we know that x equals 2 and x equals 7 are vertical lines. So maybe we'll do that now. It says graph the system. Okay. And it says just on this first quadrant. So let's begin with this tricky one. All right. X equals 2 is a vertical line. So even if you don't want to do it this way, we'll do it this way. All right. So x equals 2 is a vertical line. X equals 7 is a vertical line. And because it's less than or equal to or greater than or equal to, we use solid lines. When we graphed this, we found it was in between. This is also in between. So I'm going to shade, kind of diagonal, this strip. So on this example, you're going to end up with like a vertical strip like that. Okay. Now, we have to plot x plus y is less than or equal to 15. Okay, so I'll do that one next. 7. All right, so now I need to plot, and I probably won't have the room on my paper, so I'll move into this extra one. X plus y is less than or equal to 15. We should remember how to graph that from the last section, but remember you first treat it like an equation. We got to find our x and y intercept. So x-intercept, it actually should be very easy. And so the inequalities you see in this section are going to be pretty easy because the objective is the stuff at the end, the stuff I showed you a while ago. So let y equals 0 solve for x. So I'm going to try to show all my work on this line here. So x plus 0 equals 15. Of course, x plus 0 is 15. So x is 15. That is the ordered pair 15, 0. Okay, so 15, 0 is right here. Of course, you probably already see that the y-intercept is basically the same thing. The y-intercept is going to be 0, 15. I'll go ahead and show you. So let x equals 0, solve for y. 0 plus y is 15. And yeah, look, you get the exact same result. So that's the ordered pair 0, 15, which I can easily plot. You're going to probably get to where you don't even have to do that work. You can save some time on this already long question. So let's go ahead and graph the resulting line. So, before we move on, we have to figure out where to shade. We're going to test a point. We're going to test 0, 0 because it's not on the graph. So, x plus y is less than or equal to 15. Is 0 plus 0 less than or equal to 15? Again, you don't even have to look at that. You already could do that in your head. This is true. So you're going to shade on the half plane with the point 0, 0. Okay. All right. I kind of went at a diagonal. I'll do horizontal here. You can use multiple colors. You can use one color and just do different directions. But you should see that these lines all meet in this trapezoidal shape. So this will be for this particular problem anyway, this is going to be the resulting shape for most of those, for that particular problem. So it's a trapezoid. It's easy to find your corner points by looking at the graph. So I'm going to use the graph because it's here, but I think I need to show you how to find the corner points if they didn't give you a grid and you had to graph it yourself. Okay, so let's see, graph the system. So let's do. So my corner points are, we don't have to label them as anything, although in this particular problem, they give you the vertices or the corner points, so then you can check to see if your graph is correct, because then you know it'll be these. But in this problem, I took away the corner points, so we have to find them ourselves. All right, so I guess what I'll do, I guess I could label these. They're not labeled. A, B, C, D, if you want to do that. Okay, so my objective function is z equals 14x plus 9y. A was 2, 0. B was 7, 0. C is 7, 8. And D is 2, 13. Okay. And so we plug those or substitute those into our objective function. So z equals 14 times 2 plus 9 times 0. That's easy. That's 28. Now we'll do this one. C equals 14 times 7 plus 9 times 0. Well, I don't know what 14 times 7 is. I got to do that one. 98. So far, 98 is the maximum. Z equals 14 times 7 plus 9 times 8. Well, that one's certainly going to be bigger. So 14 times 7 plus 9 times 8 is 170. So that's the winner right now. And then let's see this last one, 2, 13. All right, 14 times 2 plus 9 times 13. 145. So it looks like the winner, the maximum, is this. So I am going to show you how to find these points, but I'm going to do that after we just finish this problem. All right, so graph the systems, we did that. The vertices occur. Well, I showed you where the vertices are. And then lastly, it says, complete the statement below. The student can earn a maximum amount of money per week by tutoring. Oh, well, what is tutoring? Tutoring is X, so I got to remember X is tutoring, and Y is TA. Okay, so back to this. All right, now we can answer this question. So it looks like 7 hours as a tutor and 8 hours as a TA. And the maximum amount they could make is 107. So there you go. So that's this problem. They were generous because they give you the corner points, and we are able to easily find the corner points by graphing it on this grid. But what if we have to find the corner points? Like, what if we had to graph this on our unlined paper and our graph is not perfect? So let me see how I could do that. See if I can fit that here. All right. Well, I'm not worried about those two. Those two guys should be easy. Those are obvious. To find C, we'll go ahead and say to find C. Since C intersects, find the intersection of, it's the intersection of these lines, right? So X equals 7 and X plus Y equals 15. And to find D, we'll do the same thing. Intersection of X equals 2 and X plus Y equals 15. So this is simple. It doesn't seem simple, but basically you've got a system of equations. And in this case, you know X is equal to 7, so you can use substitution. And so you can substitute X equals 7 into the first one. X plus Y equals 15. And then we're going to let X equal 7. So 7 plus Y is 15. So Y is 8. That is the ordered pair 7, 8, which was one of our ordered pairs that we found earlier. 7, 8. And then to find the other point, other intersection point, you just find out where the points intersect. So to find D, find the intersection of X equals 2, because that's what this line is, and X plus Y is 15. Okay. In this case, one of our lines is vertical or horizontal, so it makes it very easy. If two of your lines were like this, to where they're like diagonal, you would just set them equal to each other, just like a normal system of equations. So if we set this one up, X equals 2, it works the same way as before. Use substitution. use substitution. You have x plus y is 15. We're going to let x equal 2, so y is 13. And so that's the ordered pair 2, 13, which matches up with what we had found earlier. Okay. So sometimes you have to do that. Fortunately, in this example, you didn't because you could use the graph. But if you have to graph it yourself, there's 2 or 3 where you have to do that. You may have to use systems of equations to solve it.